So let's start for 15 minutes of presentation. So good morning, everybody. Thank you for attending this first remote PhD meeting session. And of course, we hope next time it will be, we can be together in the same room. So the idea of this presentation is just to provide you a short introduction about what is sustainable ICT or what could be sustainable ICT. It's a topic that we could talk for hours, so I don't have time for that. So it's just a short introduction. And for people that already know a lot about this topic, sorry, it's just an introduction, so maybe you will not learn a lot of things. It is more designed for people that don't know anything about this topic to help them to understand the key challenges. So first, let's start with the context. So if we are talking now about sustainable ICT or whatever other topic about sustainability, it is because of something that is named global warming. So, but okay, why not? Okay, so we have been talking about that for several years now. But what is the source of this global warming? And it is due to the energy fossil consumption. And here you have the primary energy production in the world and by source. And you can see that on average, 80% of the energy produced in the world, so primary energy, so every energy, is fossil energy. And you have oil, coal, and gas. So the oil, coal, and gas provide us 80% of our energy today in the world. And it is thanks to this wonderful source of energies that we have our society today. So we can thank the fossil energy because without it, today we will have nothing, in fact. And if you try to look at the renewable energy, you can try to have a look. It's even less than 10%. So even if we have been talking for renewable energy for 20 years now, it is not more than 10% in the primary energy production at the world level. But you could say, yes, but in Belgium, it's okay. We have a lot of renewable energy, but sorry, it is the same. Belgium relies mainly on fossil energy. So it is like that. It is a fact. And so now we are trying to work on that. But right now, it is a fact that we rely mainly on fossil energy. And this is why we have this global warming. So this is to give you the context. So, okay, now, but what is the link with sustainable ICT? Because ICT stands for information communication technology. So, okay, yes, he's talking about energy, but okay, I don't understand. And in fact, there is a link that is related to the CO2 emission because you cannot see, but when we are using a numerical device, for instance, smartphone, or when we are using a data center or whatever, internet, in fact, it uses energy. It uses energy. It is like that. And as 80% of our energy is fossil energy, then we have CO2 emission. So what are the targets? If we want to stay below 2 degrees, we have to cut by half the CO2 emission by 2030. So in 10 years, it should be divided by 2. And then we have to divide the emission after 2030 for 50% again. So the more we wait, the more difficult it is going to be. And here you can see two trajectories, so in red and in blue. And so this is like that. If we want to stay below 2 degrees, we have to do that. It's just a fact. And then maybe we will not do it, but if we want to do it, it is like that. So this is the context. And now, okay, I talk about energy and CO2 emissions. And so we will try to understand why it is related to information communication and technology. If we have a look about greenhouse gas emission or CO2 emission, for the sake of simplicity, we'll say CO2 emission. If we have a look at it, and the carbon footprint of the ICT is higher than the carbon footprint of every plane in the world. So it was in 2013 that we had the same level, but now it has reached 4% of the CO2 emission in the world, and all the planes in the world is about 2.5%. And if we follow the business as usual, BAU trajectory, we will reach the CO2 emission of all the cars in the world in 5 years. So in 2025, so 8% of the total emissions. And in fact, it is exponentially growing. So maybe in 2030, it will not be two times, but 3 times or 4 times. So we can see that the digital greenhouse gases emissions, it is not just something that is small. It was small 20 years ago, but now it is not small. Because imagine all the planes in the world. It's 25,000 planes in the world. It has a carbon footprint that is smaller than the total of the ICT in the world. So this is something big, and we will see why the ICT has this huge carbon footprint. In fact, the digital energy consumption, almost half of the energy is used to build the equipment. So it means that when we buy a digital device, for instance, a smartphone or computer or whatever it is, approximately half of the energy has been used to build the equipment. So the carbon footprint is already set by 50% when we buy it. We can't do anything about it. When you buy something, it has already a carbon footprint. And then when we use it, of course, we use energy, and then it will do the other half of the carbon footprint. But this is something I think that it is important to have in mind. Almost half of the energy is used to build the equipment. So it's not just that easy just to say, okay, I will try to use a little bit less my device, because the carbon footprint is already there. So there is this fact, and also the number of digital device was about 20 billions in 2010, and it is expected to be to reach 70 billions more by 2030, so in 10 years. So this is huge, in fact. So it is exponentially growing. And most of these devices are not just about smartphones or data center. They are about IoT. So IoT means Internet of Things. And they can be, for instance, sensors that you can put into your car, into your house. And then you can send a lot of data and then maybe try to process it to optimize your way of life. But most of these devices are just very small sensors. And there is a lot of these devices that are going to be produced. So this is a question to be raised, is that, okay, right now, on average, we have 2 devices per person at the world scale. Of course, in Africa or in the USA, it is not the same amount. It is more like 10 in the USA and less than 1 in Africa. But on average, in the world, it is 2 devices per person. So for an amount of 15 billion devices. And it will reach approximately 5 or 6 devices per person in 10 years. So, but as the carbon footprint has already been set by 50% just by the production, you can imagine the increase of carbon footprint emission. Okay. So, in fact, it is a systemic design issue. Our economy is relying on supply and demand. It is like that. And the problem is now that we could speak a lot about that, but the problem is that now most of the next 50 billion device will be designed for comfort, but not for the environment. But it could be good to have device designed for the comfort. It is not the problem. The problem is that they are not designed also for the environment. And the thing is that the short lifespan, most of the time, is induced by software obsolescence. So it means that, for instance, your device could be very well working for several years. It could work. But due to software updates or whatever, it will become obsolete. And most of it is based on the vendor's business model. It is product-centric. So it means that the more the products are sold, the more business there is. And it is a problem because it incentivizes people of buying more and more and more new products. Instead of having a service-centric business model, where, for instance, imagine you have a service-centric model. So, for instance, let's take an example with a smartphone. Imagine that you cannot buy a smartphone, but you can just buy the service of having a smartphone. So the smartphone does not belong to you. So you go to a provider, you buy the service, and you will have a smartphone. But the smartphone doesn't belong to you. You just pay a service for it. So it means that if you will not care about the smartphone, the product, in fact, in terms of lifespans, will be different, because the people that will provide you this service, they will try to have a smartphone that will have the highest lifespan possible, because they sell you a service and not a product. So we could change this business model. So, okay, but you could tell me, yes, it's true that digital volumes grow, okay. But we have the energy efficiency, so it's okay, because each year we have new innovation, and so we consume less of energy, so it's okay, it will balance the thing. Maybe true in a sense, but not totally, because the thing about energy efficiency is that, yes, it grows, that is true, and it is a good thing, but it grows slower than the volume. And you have a ratio of 2. So each year you have 30% of volume more for an energy efficiency that only grows over 15%. So that is a problem. The energy efficiency cannot itself balance the volume growth. There is also some other things, such as that screen time has increased by a lot in the recent years, so we use more and more digital device. There is also an inflation of definition standards. Now we have a curve. Today, I don't know what it will be, but so we can watch video that have a very high definition. And sometimes we can wonder, why do we really need that? Okay, why not? We have also the mobility and streaming. Now we can watch video everywhere. We can use device everywhere instead of fixed or broadcast things. And also the GAFAM business model is based on audience monetization. So it incentivizes people of having addict behaviors. So I think that it is important to have in mind that energy efficiency will not continue to grow as fast in the next 10 years as it did in the past 10 years. And even now, it cannot balance the growth volume. So we are approaching the limit of current technology, and there will be no major technological breakthrough in the next 10 years. So we could say that no solution for 2030 will come from technology. But in 2030, we should be able to divide the CO2 emission by 2. So there is a problem. So how can we do that? How can we achieve the target of 2030? The overconsumption trend is a systemic issue. In fact, most of digital consumers are unaware of the impacts on the environment, health, and behavior. Enterprises engaged in digital transition do not take into account the environmental or energy constraints. Most of the time, public authorities are encouraging digital transition. That is a good thing. But for them, it meant to yield economic growth without having defined it. Dominant digital suppliers such as GAFAM rely on audience maximizations and are trying to deploy addict design technique. And there is a software-induced obsolescence. So how can we change that? By a systemic approach. The first thing is to inform consumers with the media, public policy, to inform enterprise and company, to enable augmented digital transitions, and to demonstrate to public authorities the negative impact of digital overconsumptions. And so we could also use European market power to influence digital supplier. So, in fact, it is more about education and informations. The more we are educated and the more we are informed, the easier it is to change behavior or to make reliable choices. So to conclude, in my opinion, technology is not a problem in itself, in fact. The question are, what do we want to do with technology? What kind of society do we want to build? And how can we use the numeric or the ICT IoT to help to answer these questions? For me, it is more about that. It is to raise these questions, and everybody can raise this question and try to answer it. So this was just a short introduction because I already reached my time limit of 15 minutes. And if you want to go to dig deeper, there are a lot of reading material about this topic. So I put here some references. You have some reading materials that are not only focused on sustainable ICT, but also on energy or whatever. So you have several books. And you have also web material. And there is something that is really nice. It is a Sustainable ICT Summer School that was organized in September of this year at the UCL. And they put on the website all the materials. So if you want to have a look, it's here. So for instance, you have all the day of the summer school, and you can download the presentation of people. So for instance, there was a lot of talk about ICT. So here, for instance, there is a talk. You can have download the slide. You can download the podcast. Sorry. And it was a really nice summer school, and it was the first summer school about sustainable ICT. So it means that things are going to change, and maybe next year they will organize a new one, and I encourage you to attend this summer school. That is really great. So thank you for your attention, and if you have any question, I think we have a few minutes to answer it.
Thank you very much, Jonathan, for this very interesting presentation. So if you have any questions, don't hesitate to ask them directly.
Go ahead, Benjamin.
Right. Okay. Yes, I'm just wondering, where is the information? Where did you get the information about the no breakthroughs in the next 10 years?
This one, it comes from every people that are working in the field of sustainable ICT. So for instance, when I was attending at this summer school at UCL about sustainable ICT, so there were some professors of the field, and each of these people, each of these persons were saying that in the next 10 years, we will not have a significant breakthrough that will help to divide by, for instance, by 10 the energy consumption.
All right, so we can find this information in the UCL summer school.
For instance, or on every report of people that are working on this topic. So it's just most common knowledge that now people are admitting that we will not have major breakthrough in terms of energy efficiency.
Okay, right.
In some cases, we are even close to the theoretical limits, like for heat dissipation, we are close to the Shannon limits. So for entropy built into the system, so we know that we cannot improve much in that regard. But for some software perspective, we still have room for improvement. So on the software side, we had a lot of increase in processing power, and we grew lazy, and we use these technologies which are easy and fast to develop, but which are not necessarily optimized. And now there is a trend back to doing some optimization to reduce the computation cost. So maybe there is still room for improvement on the software side.
Yeah, sure. There is plenty of room for improvement. So that's why the energy efficiency is improving each year, but unfortunately, it does not improve as fast as the growth volume. That is a big problem. And you have a second thing. Yes, maybe we can work on the computing efficiency, and I think it is a good thing. But the other thing is that we need materials for every IoT devices or ICT devices. And sometimes we forget about that we just need some materials. We need to build these things. And half of the carbon footprint and the energy consumptions comes from these materials just to build the equipment. And they are limit physics about that, because you need to extract this raw material. They are not just there, so you need to extract these materials. And so you need energy to extract this material. And most of the times, we need to mine to extract this material, and we need fossil energy. Because today, you don't have trucks, big trucks with hydrogen trucks, for instance, that will take the raw material. It doesn't work like that. And that is a really, really big problem of all of these things. So yes, I think there is plenty of room for energy efficiency in terms of software computation. I think it is a good thing to do that. But on the other part, it is very hard to decrease the energy consumption and also the carbon footprint when we build this equipment. It is very, very difficult.
Okay, thanks.
So Antoine, you have also a question?
Yeah. Thank you, Jonathan. Yeah, it was about when you showed a plot where you showed that data center were using almost 20% of the energy related to ICT. But I heard that like Google and Amazon, they said that all their data center are fully renewable energy powered, supplied. So can you say something? I know maybe it's just they say that, but they still use the grid and so on, or is it really using renewable energy? And then you should maybe put that off your plot to really show the consumption related to the CO2 emission, or can you say maybe something like that?
Yeah, sure, I can say something about that. So the first thing to have in mind is about this plot, it was the energy consumption. So you have the energy consumption, that is just energy. We just need energy to run these equipments and to use data center or whatever it is. But then this energy, it can come from fossil energy or it can come from renewable energy. That are two different things. Here on this plot, it just shows you the energy consumption. It just tells you that data center, on average, uses 20% of the energy about every informatic device. So that's the first thing. Then, as you say, now Google or Amazon, whatever, they are trying now to produce themselves the energy to feed the data center. So like that, they will not rely anymore on fossil energy. So if they succeed to make a transition and, for example, to build PV plant or wind farm,
they already said that Google said, for example, that he is powered fully by renewable energy. 100%.
So yes,
and Amazon was 50% in 2018, I think.
Yes, but there are two things. So okay, every company now is saying that. So some of them are really trying to do it, and that is a really good thing. But you have to have something in mind, is that even if you have a wind farm or a PV farm, it is not green. It doesn't mean anything green. So the PV on the wind farm have a carbon footprint, because you need material, raw material to build this wind farm and PV farm. But of course, it is better than just using electricity from a coal power plant. So that is a good thing that they are trying to switch from fossil energy to renewable energy. So it is a good thing, but they will never reach a zero carbon footprint. It's impossible. So they will decrease so it's a good thing. But as you can see on the plot, it is 20% of the total energy consumption. So maybe they will decrease it by 2 the carbon footprint related to this 20%. So it's a good thing. But it just half part of 20%, and then you have to work on the other 80%. So that's why it is a very difficult problem. You have to work on all the topic at the same time. So the energy consumption, the raw material extraction, and whatever. So, but that's true that they are trying to switch from fossil energy to renewable energy to feed the data center. And this is true.
Thank you.
Welcome. Liège?
Yes, can you hear me?
Yes.
Hello? Yeah.
Yes.
I just would like to add that yes, Google and Amazon say that they want to be zero emission, etc. But that's bullshit. The business model of Google and Amazon is built on advertising. So the business model of Google is to make people buy things they do not need and to overconsume. So, for example, if we forbid advertising in Belgium for some reason because we want to make people consume less, the business model of Google will evaporate. And the same thing for Amazon. So they can say that their data centers are working with green energy. So, and they don't talk about the way the gray energy to build their own servers, but regardless of that, the business model is it's not good for the Earth. So I don't know what you think about that.
Yes, it is a question of what do we want to do with technology. It is always the same question for me. So I am just trying to give you some perspective, but I am trying not to take a side because I don't want to influence you. But so that's why I say that we can all raise the question: what do we want to do with technology? Because technology can be good for doing something and can be bad for doing something else. So, for instance, I could say that for me, I just speak for myself right now. That for me, if all of this technology, whatever is the business model, just forget about the business model. But for me, if it has a zero carbon footprint, I could say, okay, do whatever you want to do. I don't care. If it is just for advertisement or I don't know, I could say, okay, do whatever you want to do with it. I don't care. But the problem for me is that it has a carbon footprint. So for me, it is a problem. For some people, it is not, but for me, it is a problem. So I could say, okay, this business model incentivizes to have a high carbon footprint. So for me, now we need to raise the question, what do we want to do with that? So yes, it is, but it is complicated because now we have all of this business model and Google or other GAFAM are relying on advertisement, and it is a problem. But on the other part, sometimes their service may help us to find some solutions. So we have to find a way in that to, for me, to achieve the carbon footprint targets. But I agree with you, you can work on the energy consumptions. You can spend a lot of energy to try to decrease your energy consumptions. But if on the other part, you are incentivizing people of using a lot of electronic device, it's difficult. So it's always the same question. What do we want to do with technology? And I think we need to have a big discussion in democracy, I suppose, if we are in democracy, to try to understand this challenge. Cyril, no? Yes, Cyril.
Yes. If we zoom out, do we have studies about the global carbon footprint? But when we consider also that ICT helps to decrease carbon footprint emissions in other areas. So for instance, some of those IoT devices, which are expected to be seen in the next years, a lot of them are used in the industry to optimize industrial processes. And do we have any idea what the overall balance is with regards to what we consume in the ICT and what gains we have in other areas?
It is a good question, and it is very difficult to answer because it means that we would, to answer this question, we would require to try to categorize the usage of ICT and to say, okay, these ICT devices, IoT device, will bring this service. So we calculate their carbon footprint, but the services help to decrease some other usage. And so it is a very, very difficult question to answer. I cannot answer it myself because I don't know it. So maybe there are some studies about it, but it is true that some of these devices are good because they help to prevent from using energy. So for instance, for instance, if we just do a remote meeting like this, imagine that it was a conference at the other end of the world. Of course, we will all have taken planes or whatever, and so we would use a lot of energy, and we are just doing a remote meeting, and of course, it has a lower carbon footprint, a smaller carbon footprint than a physical conference. It is true. So in this sense, we could say, okay, here it helps to decrease the carbon footprint. So there are some usage where it might be smart to use ICT. And the key question maybe to raise is, what are these usage? Where ICT or device or algorithm can help us to decrease the overall carbon footprints. But it's always the same thing. What do we want to do with technology? So it is true that some of the next device will help to decrease the carbon footprint. But would it be enough? I cannot answer these questions. I just can tell you right now that for the past years, it has not been the case. It's just the fact that the carbon footprint of all the ICT field has just exploded right now, but maybe it will be different in the next years. But I think we need to ask the question, to raise the question: what do we want to do with technology?
Okay, thank you again, Jonathan, for this really interesting presentation and discussion. I guess that we will hear, I hope, more and more about these subjects in the future, and maybe about politicians. It would be nice.
Thank you for your attention. It was really nice to speak about this topic with you.
Cool. Thank you very much.